Berlin Airport, the location of one of the most modern fire stations in Germany. The rescue team needs to be at the scene of action within seconds. It's a matter of life and death. This high-tech fire engine takes center stage.
You'd be hard-pressed to optimize this vehicle any further, unless, of course, it had a rocket engine and could fly. But we're satisfied with it as it is. This is state-of-the-art, very nice, great to work with.
Good is not good enough. The engineers have taken on the challenge of improving upon an already perfect vehicle. The aim is to create a super fire engine on 6 axles. Firefighting vehicles have been produced here in Giengen in southern Germany for more than 100 years. Everything here revolves around fire and flames. Now, the developing team intends to build the world's most modern firefighting vehicle, and that in all areas.
We've
also done a great deal in terms of comfort. In the chassis, for example, we fitted 2 shock absorbers onto each axle or wheel to increase comfort when the vehicle is en route. But the absolute highlight as far as the chassis is concerned is our continuously variable transmission. We now have the ability to transmit full power to the road from start to top speed without interruption, and you don't have to struggle with any switch cycles or conversion losses.
This is not just any crash tender. This is about constructing a Formula One car on 6 wheels. In the past, a model would be drawn by hand, but today, this is done in 3D, using a computer.
We work with the design program Creo. We work in 3-dimensional space and design all the components here, from the whole vehicle right down to the smallest detail. Every single screw is specified, its position, its design. The vehicle concept for the new set class includes various individual vehicle modules that differ from one another in terms of function or placement. For example, the driver's cab, the water tank, the piping, the pump, and the cladding.
Everything has its place inside this giant. That's exactly what spurs men like Lukas Klemt on. He wants to push his computer to the limit. But if someone makes a mistake during construction, a domino effect ensues. That's why men and women work as a team and are in constant dialogue with one another. Once the PC modules have been approved, it's time to move from the virtual to the real world. A 3D animation becomes a real component.
We are in the process of manufacturing the new Z-Series. Here you can see the piping with the entire pump unit, which is then prefabricated in one piece. At the core of everything is the firefighting centrifugal pump, which can pump at a nominal value of 10,000 liters of water per minute and is mounted on a special base frame which has been designed especially for the purpose of prefabricating the entire piping and then placing it on the vehicle in one piece.
The new Z6 is designed and built specifically for airport emergencies. The on-site security force leaves nothing to chance. While accidents are rare, they are often serious and life-threatening once they do occur. That's why drills are scheduled daily.
Morning.
Hi, Benny.
The Fire Training and Education Center is ready to proceed with the drill.
All right.
We've chosen the FLF Z8 type Ziegler for today's drill. What would you like to focus on today?
Well, I think we should focus on the handling of the articulated arm, the water tower, and the piercing tool. We'll certainly use the piercing tool on the dummy.
Exactly.
I guess we're looking to make sure the vehicle is in the right position, and I'm looking to make sure that the extinguisher is used correctly. Today we'll only be using water for training purposes.
Right, okay.
Let's get going. I'll call the control center to sound the alarm.
Great, then we can start.
Yeah, hello, Oliver here from Control Center. We'd like to start with the aircraft fire drill using the Z8 now. Sound the crash horn, please, and then we'll get started here. Okay, all right, see you later. Call you when we're done.
The men and women have to be on alert every second. This is not a case of rescuing cats from trees. It's about putting out infernos and rescuing people from burning planes. They have to remain calm and should not panic. They must use their given technology with extreme precision, common sense, and trained tactics. At the heart of it all is the control center. It monitors every action and coordinates the rescue teams. One wrong move can cost lives, so the professionals are highly focused. An aircraft fire is not a matter of minutes, but seconds. Accordingly, stress levels run high, even during drills.
Warning, there will be a test drill for the crash alarm in all 3 fire stations. This is a crash alarm test drill. Yes, drill is about to start. Yes, understood. Starting the drill.
Now, the time is running. Every step, every move has been rehearsed 1,000 times and perfected again and again. Ultimately, everyone's sitting on 1,000 horsepower, which virtually catapults the mega crash tender to the scene of the accident within seconds. Director of Operations Benjamin Christ is always on site. The time factor is important for him and his team, and this is to be optimized further by new technologies.
We here at the airport in our fire truck would also like to make more progress in terms of digitalization. For this, we need navigational aids similar to those used in cars, but specially tailored for the airport, with taxiways on them so that we can respond even faster during deployment.
The crash tender has to be able to reach every corner of the airport within 180 seconds. The men in the cockpit have already started fighting the fire while approaching the site. This is just a drill. In a real emergency, the crew and passengers would have to be rescued from the inferno. Group leader Lars Voss is aware of this responsibility and also sees the real disaster in every drill.
We have 12,000 liters of water here, as well as powder and a foaming agent, of course. We try to cool the cabin down, extinguish the fire along the way, and cooling is so important here with this burning object. We have a lot of people concentrated in the fuselage. Of course, these people all have to be saved in case they have not been able to escape by themselves. And that's why we cool the aircraft as much as we do. The quantities of kerosene are considerable. And we try to keep them under control with foam.
Seconds are at stake, not just during the approach, but also at the scene itself. Within a very short space of time, enormous quantities of water need to be pumped out of the tank and out of the hose. The vehicle is designed specifically for this scenario. A real powerhouse that needs to be operated with absolute precision.
The vehicle's performance data is excellent. Technology? We're still firefighters and actually super hands-on. There are a lot of new technologies here that you have to be able to operate on a daily basis. And that's the real challenge.
This is where the next challenge is being built. At the heart of every fire truck is the pump. The casing requires special care. It's subjected to enormous pressure during operation, which is why absolute precision is required when milling the socket. The specialist checks and double-checks every recess and radius.
I have now checked my thread, which is fine, and also the thread depth. My complete diameter is also good. Now I can just let it run.
Depending on the size of each vehicle, the experts manufacture different sized pumps.
Under normal circumstances, we get the drawing with the order, put it inside, and then it runs automatically. Everything gets stored.
The casing has to withstand not only pressure, but water too. That's why the engineers have developed a component that is light, resilient, and rust-proof.
Here we mostly use an aluminum alloy, which is for the water-bearing parts. It has a very low silicon content so that it's more resistant to corrosion.
After the black protective coating has been applied, staff can assemble the casing with the other parts. The work is so complex that the most important modules and elements are not outsourced, but rather manufactured here on site and positioned like a puzzle. Although the pump is supposed to be more powerful with each generation, it has to decrease in size and weight at the same time. The lighter the vehicle, the faster it gets to the source of the fire. The goal of the technicians is always to achieve the optimum. The more efficient the vehicle, the more lives it can save in an emergency. Every screw, every thread, every hose is devised and tested for this. In the end, the pump is put on the test stand and subjected to almost twice the pressure that would normally be used. 17 bar of negative pressure are built up. Now it will become clear whether or not the thread screws and weld seams will hold.
2 minutes after the negative pressure, we check to see if it remains constant, and if that is the case, the pump is actually watertight and protected against negative pressure.
But that's not all. Now, an auxiliary pump is added, which offers another advantage in the event of an aircraft fire.
There is a separate high-pressure pump on top of it. With this, we can project water further, at around 50 bar, at high pressure and with less water.
This allows for a greater distance between the fire and the firefighters, which adds additional safety for them. Alongside the pump, the so-called launcher is an important component on the airport crash tender. This is not any old garden hose thread. No, this is the Super Bowl of high tech and the pride and joy of the software developer Ingo Boden.
We're taking a completely new approach with these launchers compared to the ones we've built in the past. We're using so-called intelligent motors that give us feedback on how they're doing, position, temperature, current. And that also enables us to get the appropriate diagnostics about the launcher. The key word here is remote maintenance telematics, which was previously not possible with the old launchers.
As with remote measurement in motorsports, this allows important data from mechanics and electronics to be retrieved more quickly during operation. The crew can react immediately, rectify the problem, or redirect firefighting efforts. The vehicle reports weak points before damage occurs, making operations safer. To ensure that firefighting is as efficient as possible, the vehicle is equipped with 2 launchers. One is installed on the large swivel arm. The second is located at the height of the driver. Both can be controlled individually and steered with different operating modes.
As far as the vehicle is concerned, put simply, it all comes down to how fast it can go, how much water it can hold, how far the articulated arm extends, how well the pump and roll function works, and how much water can be produced on approach. There are 2 drive motors on every vehicle, which reach a top speed of 135 kilometers per hour, and each vehicle can operate the pump motor while simultaneously maintaining the power and spraying water. Saving human lives is the most crucial thing here. Material assets can be replaced, human lives cannot. That's our job, and that's what we train for.
And they do this regularly, so that everything runs smoothly, especially in stressful situations. The firefighters don't have time to think. They have to be able to move blindly in the cabin.
The vehicles have become so technical, and we, as an on-site fire department, don't stick to the standard model. We can build our vehicles according to our needs, and that's what we've done here. This is what came out of it, and we are actually very pleased with it.
This is because firefighters are indirectly involved in the development of new vehicles. Their everyday experience is incorporated into the design of new models. As airplanes evolve, so do the demands and requirements placed on firefighting technology. In addition, there are certain regulatory requirements and regulations that have to be complied with.
According to aircraft regulations, this 180-second arrival time, the time it takes the fire service to arrive at the scene and use extinguishing agents, has remained the same. Nowadays, we have vehicles with engines that are so powerful that we can continue to shorten these arrival times and achieve higher final speeds.
Whether or not the vehicles can reach these speeds is being tested at the airport in Memmingen. The vehicle runs through braking and driving scenarios on a runway closed specifically for this task. Tobias Quintenz pushes the Colossus to its limits.
Even when it's full, it drives extremely fast. It actually accelerates without the shift pressure you usually get from changing gears. So it's constant. And this makes a huge difference compared to the old gearboxes where you felt everything. Those were real shocks. You don't have that anymore with this vehicle. It actually accelerates from 0 to top speed. So it's really nice without much shift pressure. And it's just a new driving experience that you have to get used to.
During situations like these, technicians and engineers get real-time feedback from the vehicle. They log and test the driving, the power delivery, the extinguishing modules, but also the braking force. The temperature of the tires after the brake test is also measured.
(630, 687 degrees.
Okay.
After a hard stop.
That was an acceleration run from 0 to 80, and a subsequent hard stop from 80 to 0. The deceleration performance was very good. The temperatures all remained within the expected range, and the performance, what we could do with the hand stopwatch, looked good. We won't get the exact data until we evaluate it completely with the laptop.
The men continue refueling the vehicle and sending it out on the track again. They're well aware that one of the most powerful firefighting vehicles in the world is being tested here. It has to meet expectations in China as well as in Dubai. It has to perform in snow and ice, just as well as in sweltering heat. This time, the technicians want to reach the top speed with a full tank and while spraying water.
After refueling and before we drive at top speed, we check the tire temperatures and the axle temperatures by hand, so that when we reach those top speeds of over 120 kilometers per hour, we can be sure that nothing will happen to the tires.
The 39-ton vehicle picks up speed again on the red-hot asphalt. Extreme conditions for man and machine. And of course, the testers also take a close look at the pump and the extinguishing arm with launcher. The tank holds 12,500 liters. The contents are sufficient for 4 minutes. Then the fire must be extinguished, or if necessary, the crew needs to fill up the tank again. The water jet has a range of over 100 meters. This shows the power the pump can unleash. The developers have put a particularly large amount of innovation into the pump. During the ride, the most diverse modes are tested on the launcher. from swinging out horizontally and vertically to the variables of the spray head.
We are now doing a driving profile, which is where you approach a burning object or a burning aircraft, mainly for landing gear fire or engine fire. This means that the extinguishing arm is set to the lower attack position. It's simply about looking at the dynamic movements of the arm at slow speeds, whether it's bobbing, whether it's stable, and so on. With this approach, the firefighters bring this arm into the lower attack position when starting the vehicle up and when slowing it down. Then they go to a low walking speed before approaching the burning object at slow speed. And that's where we want to see if all the mechanical stuff is stable to the point that it doesn't swing too much. It will always oscillate, but there is a certain limit that it must not exceed, and we will now try this during the next drill to have the arm oscillate correctly.
It's not just the latest technology that has been installed, but also the world's largest driver's cabin. This is to ensure that the emergency team at the airfield have an all-round view and can always keep an eye on the fire. It's these superlatives that make the crash tender into a super fire engine. And it's thanks to the meticulousness of these men that the Z6 is both strong and highly efficient at the same time. Communication within the team is always important. These are professionals who know their craft.
Toby, why don't you take it to stow position?
The men still have to run through many scenarios with the vehicle. Above all, the different extinguishing modes that have to be tested. All data is stored in the computer and forwarded to the headquarters in Giengen for evaluation. There, preparations are made for assembly. The workers are now assembling all the modules. Ultra-precise work, not only in production, but also during assembly. Does everything that was previously calculated in 3D animations fit? The base of the new airport crash tender is its chassis. At the end of the assembly process, the vehicle has an impressive length of 11 meters. A real giant that the engineers, nevertheless, want to be lightweight.
The main issue is weight distribution. We have a maximum axle load of 13 metric tons on each axle and a total weight of 39 metric tons on this 3-axle vehicle. We try to keep everything super light, the components too, and the lighter we are, the greater the advantage for the customer. Everything we have on the vehicle in terms of light technology enables our customer to carry more water, more extinguishing agent. In this vehicle series, we can carry up to 19,000 liters of this agent, that is, water or foam, depending on the body and the system.
Depending on the size and requirements of the airports, different models, chassis, and engines are installed.
We have different sized chassis here, from 2-axle to 4-axle. We always have an axle load of 13 metric tons per axle, which means we start with a 2-axle truck with a total weight of 26 metric tons, then a 3-axle truck with 39 metric tons, and finally a 4-axle truck with 52 metric tons. That is a huge advantage. We also drive with different engines. So the 2 smaller ones we drive with 770 horsepower. On the big one, we have 2 traction motors, which offer up to 1,540 horsepower of engine output.
Every step in the construction phase is monitored and optimized where necessary. Firefighting vehicles in particular are supported by electronic assistance systems. Without high-performance computers and specially developed software, these superlative vehicles would be impossible to handle. Above all, the control of the systems, such as the pump, must be structured in a simple way so that it's easy and quick to operate for any firefighter under stress. A failure would have devastating consequences. Firefighters benefit from technical intelligence, but at the same time, they become dependent on it. Man and machine alike experience development and challenge each other. This also applies to the sensor system for the tilt angle. The vehicle will not only be used on the runway, but also in open terrain. Formula One meets rally.
Here we have a sensor for the rollover warning device. This warns the driver when the vehicle is on a dangerous incline. We evaluate the data in the software and then issue appropriate warnings on the display and over the radio.
Airport firefighting vehicles are increasingly being used for forest fires, and their suitability for driving on difficult terrain must be ensured accordingly. Due to superstructures and the loaded extinguishing agents, the center of gravity is high. Therefore, a warning device for the tilt angle is indispensable.
Rollover warning.
All driving scenarios, whether on hard or soft ground, incline and slope angle, have to be fed into the computer systems. Every road surface, every ground condition, whether mud, stone or wood, has been simulated on the computer extensively. However, the sensor system must be set in such a way that the vehicle remains suitable for everyday use and does not sound an alarm in response to every short, extreme movement.
The speed of the deflection also depends on how strongly I set the filter. So if I have quite strong fluctuations that only last for a very short time, you will not see that at all in the display. If I just have a short bump, this should not immediately trigger a warning. If you only have short-term fluctuations, then this must not affect the target signal, which is then implicit for the PC.
The larger the fire trucks, the greater the effort.
We use this primarily in airport crash tenders because the center of gravity is a little higher and there's an increased risk of the vehicles tipping over due to their high speeds.
The simulated warning signal seems to work. But how does it look in the field? The super crash tender not only has to prove itself at the airport, but also in the forest. In recent years, the number of forest fires has increased. So the Z6 is being used more and more frequently to put out different types of fires. Florian Kubowski checks whether the vehicle is also suitable for off-road use.
This means we are investigating the vehicle's operational stability and the basic coordination between the engine, gearbox, and fire pump. So I can move the vehicle just using the normal driving operation, but have the pump switched on fighting fires too, which I can switch on at speeds of up to 120 kilometers per hour, for example. And this coordination is tested, optimized, and adjusted.
The firefighting giant is breaking new ground off-road. Until now, it has been used almost exclusively on asphalt. Now, the horsepower behemoth has to prove itself on sand, grass, and gravel.
Basically, we can say that it's the final round of development, and we're doing kind of final test rounds with this vehicle here. We have 14,000 liters of extinguishing agent on board. We have an engine with 770 horsepower, 3,500 Newton meters. The vehicle is highly optimized to ensure that we have a very quiet cabin, which also offers good driving comfort at higher speeds.
Almost 40 tons have to be moved over hills, gravel roads, and forest paths. Thanks to the specially designed driver's cab, the firefighters always have the scenario in view and can react at lightning speed in the event of danger. At the same time, one of the most powerful water pumps ever installed in a vehicle is in use. With a pressure of 10 bar, the water jet reaches over 100 meters and hits with an enormous force. This has to be the case, especially with large fires. So that the firefighters can fully concentrate on fighting the fire, the handling of the vehicle and extinguishing technology must be as simple as possible.
The vehicle is suitable for higher off-road mobility, also for forest fire operations. The large water supply of the vehicle, especially for army applications, allows the use of the vehicle in the forest. It's tested accordingly so that you can make forest trips without problems.
Thanks to the all-wheel drive, the vehicle practically sticks to the ground and handles even critical situations effortlessly. The enormous horsepower also provides the necessary thrust. The ground clearance also underlines the off-road capability and enables use on difficult terrain. The men spend 2 days testing the vehicle. Later, it has to be just as ready for action in freezing cold Siberia as in sweltering heat in the desert. Sandy ground must be just as little of an obstacle as mud. The testers leave out no scenario. Even in the forest, time is of the essence, so the accelerator pedal is pressed down as far as possible.
With the test, we ensure that the vehicle can be operated well by the firefighters and emergency personnel in normal everyday operations, that it can withstand the stresses and strains that occur there, and that the firefighter or emergency personnel can concentrate on their original mission, that is, on operating the extinguishing technology, on fighting fires and rescuing people, and that the vehicle provides the best possible support and does the job reliably.
Up to now, the Giants have mainly been piloted by men. But at BER Airport, it appears that this will change in the future. Women like Kathleen Roman are also increasingly taking a liking to the fire department.
As a woman, I decided to join the fire department, which I always found very fascinating. It was actually a childhood dream to join the professional fire department at some point. You have to do exactly the same work as the men, and then it's not so much a fight, but you're part of a team and integrate normally, like everyone else.
In the meantime, she's risen to become a platoon leader at Berlin Airport and takes the command during operations. The daily routine includes theory and, above all, first getting to know the huge grounds of the large capital city airport. The firefighters have to memorize all the important key positions and need to be able to call them up immediately during an operation. They practice all the scenarios, such as putting on protective clothing over and over again. But also the psychological impact. How are potentially dramatic rescue operations processed?
It's easy to say that you shouldn't let it get too close to you at first. But you talk about what happened after the missions in order to simply evaluate them with the team. You go home and have your family there, your normal family life. And then you switch off at home and try to get it all out of your head somehow.
Or you can simply distract yourself with work. The technology is constantly renewed and modified, so its handling must be well prepared.
We are currently preparing our equipment training so that we can briefly go over the function of the scissor spreader again. One of us briefly explains to the other colleague how it works, so that the handling always remains familiar.
The requirements and challenges are far greater for an airport fire department than for a rural volunteer fire department. Not only because the equipment is more specific and more complex, but also more comprehensive.
What's special about working at BER is that it's an airport. You have aircraft as technology that you don't have in normal fire departments. We have large airfield crash tenders, which are of course special as fire trucks. At BER, we have a rail tunnel underneath and a station, and of course, the whole spectrum of tunnel firefighting and rail firefighting as well. In itself, the BER is its own little city, where you can also experience the normal everyday life of a fire department.
From the emergency landing of an aircraft to a trapped visitor in an elevator. In every scenario, the right decision must be made within seconds, and the appropriate equipment must be used. Everything must be quickly at hand and easy to operate. These factors are extremely important, also in the planning and the design of new firefighting vehicles. However, in the 21st century, it's not just about technology and performance, but also about design. A fire truck must first and foremost be functional and effective, but it should also be an eye-catcher. Max Rudolfer is the designer behind this process.
Innovation is important for designing and interpreting a strategy. We want to afford innovative, attractive products in the future. This includes the technology, but the whole handling and the whole appearance is important too. Something that looks good is also perceived as something modern, which includes new technology and which usually also works well. Design is a visual promise about the quality and technology of what a product will have in the future. And you have to embody that, because at the end of the day, a vehicle like this, when it's at the airport, is always a representative of safety, and every passenger or every traveler feels good when they see and experience such a high-tech vehicle. And that's what a company should embody.
The look of the vehicles is becoming more and more important, without compromising their actual purpose.
For us, it's not about beauty, it's not about pleasing, it's about attractiveness and honesty, robustness.
Max Rudolfer draws inspiration for his work from various motifs and visual occurrences. Thus, the front view can sometimes be based on a predator, the shark in the fire department.
So we created guiding principles for ourselves. Something very dynamic, recognizable from the animal world, for example a shark, which combines very well the angularity but also flowing forms. We looked at constructivist forms and then arrived at a formal language via the diamond, via such an angularity, and conceived this in various stages and relayed it, always with the premise that the angularity, the flatness, is translated into visibility and see-through surfaces for the windshield. The important thing is that, in principle, the step is now being taken to bring the concept of such a cockpit from the inside to the outside, to design the driver's workplace accordingly. For example, creating the open spaces here so that they are actually transparent and can be seen through.
To immerse yourself in the visions, fantasies, and enormous creativity of Max Rudolfer, VR glasses are the best option.
So, Yannick, you can already see virtually with the glasses how the interior looks. You should now see the console in front of you.
Exactly.
With the steering wheel, controls, joystick and center console. Can you describe your impression of the cabin as a whole?
It seems in any case insanely large. The windows are clearly far away from me, and I see how enormous the space is, that there is space for several people, and also that the co-driver feels far away, which is different from a typical car layout. It feels as if the next person sits 2 meters further to the right.
However, not only can the design of the interior be displayed in 3D, but certain firefighting scenarios can also be recreated with the software in the truest sense of the word.
You can recognize the Z attack, and I think you can now also operate it spraying water.
Yeah, it's already approaching.
Then I think you can also track the water jet. You can then follow this as the water jet moves.
Even before the first tire is mounted, the pump screwed on, or the launcher attached to the vehicle, the technicians are already seeing the future of firefighting through their goggles. With this vehicle, airports around the globe will become even safer, and the chances of getting out of a burning wreck alive in an emergency will increase. Those who ensure safety must also be safe themselves. That's why the driver's cab is subjected to various standardized crash tests.
In case there's a frontal collision. And by testing other scenarios, we prevent the vehicle from flipping or from sliding against a bridge pillar.
To do this, the testers fix one of the world's largest driver's cabs to the test rig. The cab is now subjected to certain forces and must guarantee the safety of the occupants in the event of a collision. Everyone is eager to see the results following the Big Bang.
Now, in theory, we could start.
Yeah.
Now it's time for the analysis. The data from the sensors show what forces acted on the dummies and what injuries human occupants would have sustained. A personal assessment of the damage is also part of the process.
This is really nice. Everywhere we were supposed to go, we did. We've got some nice deformation here. The energy degradation is in the range of 40 to 60% in the front area alone.
Yeah.
During the crash test, the testers try to simulate a real accident scenario as authentically as possible. So, they set weights, angles, and speed accordingly.
The first test was really successful. We have enough clearance between the steering wheel and the dummy, and the cabin is still in its place, which means it is not torn off the chassis.
The second test scenario is about to take place. The testers now recreate a direct impact, for example, with a bridge pillar or a collision with another truck. A very long build-up for a brief moment of destruction.
2, 1.
To leave nothing to chance, the testers repeat the sequence several times. It would be simply negligent if a deformation or crack were to be overlooked. The findings following the test are important.
Of course, the free space, that is, the seat itself and the dummy sitting on it, must not be violated. The cabin must remain on the test rack and the doors closed. In this way, we can confirm that nothing really bad can happen to the firefighters.
Of course, the impact leaves its mark, as it should, because it's important that in the event of a collision, the forces are absorbed, that is, dissipated via the body, and do not take effect in the cabin. The firefighters at Berlin Airport can rely on this and fully concentrate on their exercises and missions. This is also the case with this special stinger. It's used to penetrate the cabin during firefighting operations.
In addition to the front monitor and the roof monitor, we also have the option of a piercing tool with which we can carry out firefighting inside cargo aircraft without having to act directly as a squad.
The fog is intended not only to extinguish the cabin, but above all, to cool it.
You have to imagine the extinguishing lance is pressed onto the fuselage, and then a lance is pierced through the aircraft skin, and this creates then a water mist inside that can fight a possible fire.
Extreme scenarios require special and innovative solutions, especially at major airports. It's not just about fighting fires on aircraft, but on the entire site.
Of course, the aviation industry is not standing still. As the aircraft would be more modern, continue to develop, and accordingly, we as an airport fire department must also meet this development, renew our fleet, and keep it modern.
And airport fire departments around the world can rely on the engineers here in Giengen. The gates are now opening for their latest development. This special firefighting vehicle is now the measure of all things. But there's no end to the visions, and the engineers are already working on the next generation. It's to be even more striking, faster, and more efficient. But as impressive as these vehicles are, the firefighters always hope they will never have to be used in an emergency.